Welcome to Group 5 presentation. This presentation is to fulfill the requirement for the subject of mold design. Before we start with the presentation, let me introduce myself. My name is Nur Fatina Jiha and my other three members, Marina Muhammad, Muhammad Nur Hakim and Kamarul Akmal. This presentation will be submitted to Sir Muhammad Faisal bin Halim and also Sir Muhammad Kamal. Let's take a look at the first slide. What is injection molding? Injection molding is a method to obtain molded parts or products by injecting plastic materials molten by heat into a mold and then cooling and solidifying them. This method is suitable for mass production of product with complicated shapes and also take a large part in plastic processing. There are 6 steps of plastic injection molding. First is clamping, second injection, third dwelling, fourth cooling, fifth mold opening, and lastly is remove the products. The second slide is the objective of the project. The main objective is to design a new part or redesign a new part, followed by mold design including parting line, cavity, gate, and runner type, and the approximate ejection mechanism. The second objective is to validate the design by using plastic flow simulation. And the third objective is to provide detailed drawing for plastic part, split core and cavity, and also mold assembly. Here, I will explain on plastic part design. So what was stated in the objective is to develop a new or redesigned plastic part. During this project, each team members were required to illustrate at least one plastic part. The plastic part can be a new design or redesign from the current product. Then, all 4 of us sat down and discussed our own idea and came up with a conclusion on which plastic part is suitable for the next process. The chosen plastic part is 3 pin plugs. Then we transfer the idea into 3D modeling by using SolidWorks software. That's all from me. I would like to pass my presentation to Marina binti Muhammad.
Designing a plastic part for manufacturability involves many important factors that touch on all areas of part: design, tooling, material selection, and production. First, it is essential to build parts around functional needs by keeping in design intent. Here are several important factors to consider to meet your plastic part design goals for a successful production process. First, wall thickness. Designing plastic parts so that wall thickness is consistent can help avoid many part defects that can occur during the manufacturing process. When plastic melts, it flows to the areas of the least resistance. If our plastic part has inconsistent thickness throughout, the melt may flow into the thick areas first, which depending on the gate location. Second, for the gate location, gates are critical to ensuring the resin flows properly into the mold. These small components of our design are what directs the flow of resin from the runners to then be distributed through the part. Type of gate and placement has an important impact on the part's overall quality and reliability. Third, draft. Draft is the amount of taper on the vertical walls of the plastic part. Without draft, a part may not eject from the mold or may sustain damage during ejection. Typically, draft angles between 1 degree to 2 degrees are required, but can vary depending on the part restriction and specifications. Fourth, ribs. A plastic part that has been designed with a minimal wall thickness will not be as strong as a thicker part, which is why the inclusion of ribs may be needed to help reinforce the part's strength. Depending on the material used, rib thickness should be between 50 to 70% of the relative part thickness to avoid sink marks. To avoid sinking, we may core out material to reduce defect risk. Last but not least, mold shrinkage. The shrinkage that occurs during the plastic part molding process can be as much as 20% by volume. Crystalline and semi-crystalline materials are most prone to thermal shrinkage. Amorphous materials are known to shrink less. Here are a few ways to avoid molding shrinkage issues, which is adjust the formulation, adjust the mold design to the dimension you want based on the expected shrinkage that will occur, and optimize the processing parameters such as mold temperature, melt temperature, and injection speed, pressure, time, or cooling time. Why design for manufacturing is important for the injection molding process? Beyond just estimating manufacturing cost, your injection molder should be using DFM principle to reduce the cost of components, reduce the cost of assembly, reduce the cost of supporting production, and to identify the impact of DFM decisions on other factors throughout the entire design and production process. Another reason for selecting a molder that uses DFM principles is the increasing complexity of plastic injection molded parts. Consideration of tolerance, draft angles, undercuts, and more need to happen in the design stage in order to achieve the quality or cost requirements of the customers. For mold design process, the first stage was the design of a completely new plastic part, but the existing part can be redesigned. The design of the part should be considered as being manufactured in two-plate cold running mold without side action. The detail of the design of the part used by SolidWorks must include functional purposes, material selection, and economic justification. For example, the cost estimation of the product and the quantity of production can be incorporated. The second stage of the mold design process involves the determination of the parting line, core, and cavity, gating, and runner type, and the approximate injection mechanism. The simulation of the plastic flow is used to validate the design. Finding the simulation result affects the next step. Only if the error can be reduced, proceed to the assembly stage. When the analysis is completed, the assembly of the mold can be done and drawing layout can be generated.
Okay, my name is Muhammad Hakim. So I will present the process to create core and cavity in this project, which is parting line, gate, runner, and event. So parting line is the dividing line that split the core and cavity half of the mold part. It is sometimes starting point for mold parting surface as shown in the slide. So two is a gate. The gate is opening in the mold through which the molten plastic is injected into the final part. It is boundary between part and the scrap. For this project, we are using a side gate. Side gate is referred to as the standard gate. The side gate is generally designed on the parting surface. The plastic fill the mold cavity for the inside or outside. Third is runner. We are using a trapezoidal runner. It is cheaper and efficient section is the trapezoid. The trapezoidal runner should be designed with a taper of 2 to 5 degree per side, with the depth of the trapezoid equal to its base wave as shown. Event. So event is uh, uh, surface in the cavity of the mold. In injection molding, molten plastic is poured inside the cavity. It is this is it is also possible to say the process is that replacing event molten plastic. It is possible to suppress the filling pressure to a lower value, and as a result, it is possible to make small residual stress in the mold product. It is possible to improve the quality of the mold product. Okay, for this project, we are using aluminium 7075. Aluminium 7075 is a high strength material with a large percentage of zinc, and it is best used for medium value project involving general purpose resin such as ABS, PP, PPE, and nylon. The pro for aluminium is common tool metal when it comes to heat transfer. It can be heated and cooled quickly. uh, Aluminium 7075 machine well, and though it may not be the less expensive material, some part of this cost can be covered over large production to decrease the cycle time. The Meanwhile, the aluminium uh, good on the heat transfer and cost. It It is still one of the least durable tool material. With this durability factor of in mind, it should be used for injecting corrosive resin such as PVC. Additionally, aluminum is not suitable for high clamping pressure.
Hello, my name is Kamarul and I'm going to continue this presentation. I'm going to present to you about simulation and the filling time. Okay, part value for this plot is 13.16 centimeter cube. The size is 50.30 millimeter times 12 millimeter times 120.77 millimeters. The material that we applied to this plug is ABS. Okay, moving to the process setup. The mold temperature is 50 degrees Celsius, and as for the ABS melting temperature is 230 degrees Celsius. Injection pressure, we increase it to 100 megapascal, and the holding time is 3.07 seconds. Okay, moving to this diagram number 2, this shows the runner diagram and the part. Okay, from the cooling channel, we start with 7 millimeters and down to 4 millimeters. And then the runner continue and maintain its size to 4 millimeters. Okay, then at the gate, it goes to 4 millimeter diameter to 2 millimeters diameter. Okay, we do this to increase the pressure so that the mold can be inserted nicely. Okay, for the filling gate, it's located at the top of the cooling channel. Okay, moving to the filling time animation. The filling time is 1.1 second. The cooling time is 8.5 58 seconds. The open mold time is 5 seconds, and the total of the cycle time is 14.58 seconds. From the diagram, we can see that the mold is spread evenly. Therefore, there is no runner balancing is needed.